Imagine facing a human cousin 3 times stronger than you, built like a biological tank, able to survive injuries that would kill a modern athlete instantly, and then realizing that this so-called brute lives on inside your DNA. For over a century, Neanderthals were wrongly dismissed as dumb cavemen, evolutionary dead ends who couldn't compete with smarter Homo sapiens. But modern science is flipping that story on its head. These weren't failures, they were evolutionary masterpieces. Creatures adapted to survive glacial winters, bone-shattering trauma, and extreme physical stress. They created the world's first industrial adhesive, practiced long-term healthcare, crafted jewelry, painted on cave walls, and possibly even spoke languages. They didn't just survive, they thrived in a world that would kill most of us in hours. And then they vanished. But not entirely. If your ancestors came from outside Africa, you're carrying around 1 to 2% of their DNA right now. Those genes help you fight infections, adapt to climates, and process pain. So what really happened to these remarkable beings? Why did evolution's most specialized survivors disappear? And how did they become part of us in the process? This is the story of the Neanderthals. Not as primitive cavemen, but as one of nature's most extreme and misunderstood experiments in human potential. Chapter 1. The Anatomy of Survival. If you saw a Neanderthal walking down the street today, you wouldn't think primitive, you'd think powerhouse. Forget the lazy cartoon image of a hunchbacked caveman dragging a club. Neanderthals were some of the most physically adapted beings evolution has ever produced. Standing around 5'6" and weighing upwards of 180 pounds, they were shorter than modern humans, but built like compact engines of survival. Dense muscle layered over thick bones, designed to withstand an unforgiving Ice Age world. This wasn't just about brute strength, it was functional design at its peak. Their short, barrel-shaped chests, wide hips, and short limbs weren't flaws but thermal adaptations, fine-tuned over hundreds of thousands of years to conserve body heat in the bitter glacial climates of Europe and Central Asia. According to the Smithsonian Human Origins Program, this stocky build reduced surface area relative to body mass, a principle straight out of physics, minimizing heat loss and maximizing internal temperature retention. Their massive, flaring noses weren't aesthetic quirks either. These were sophisticated biological HVAC systems, capable of humidifying and warming freezing air before it hit their lungs, a life-saving adaptation in climates where inhaling dry, frigid air could cause damage to respiratory tissue. Their thick brow ridges and elongated skulls didn't make them dumber. They housed eyes significantly larger than ours, adapted for low-light environments like deep forests, long winters, and cave interiors. That's not just impressive, it's visionary, quite literally. And what's even more fascinating is how these physical traits link directly to brain organization. Studies, including those from the University of Oxford, suggest that Neanderthal brains were just as large as ours, sometimes larger, but wired differently. More brain matter was devoted to vision and motor control, which makes sense when you're navigating snow-covered landscapes, coordinating hunts with large game, or surviving close-quarters encounters with deadly animals. Their cerebellum, however, may have been proportionally smaller. The part of the brain modern humans use for social fluidity, creativity, and adaptability. This doesn't mean Neanderthals were unintelligent. It means they were differently intelligent, optimized for stability, sensory acuity, and physical resilience over improvisation and large-scale collaboration. Think of it like 2 operating systems, one geared for extreme terrain performance, the other for rapid adaptability in social environments. Neanderthals didn't need startup societies or agricultural innovations to thrive. Their entire biology was the innovation. Their bones especially tell a story that borders on superhuman. Cross-sections of their femurs show a density and strength unmatched by any modern population. Their upper arms were likely capable of force 2 to 3 times that of a fit modern male. This wasn't muscle for show, it was for survival. Archaeological evidence shows high rates of bone fractures, especially to the head, ribs, and arms. And even more impressively, signs of healing. Neanderthals weren't just getting hurt, they were getting crushed, surviving, and walking it off. This points to not only insane physical durability, but also community care. Someone helped them recover, brought them food, protected them while they healed. These weren't lone wolves, they were deeply interdependent beings. And yet, the physical stress they endured was immense. Many Neanderthal skeletons show injuries consistent with hunting extremely large animals, not from a distance, but up close. Close quarters confrontation with animals like woolly rhinos, bison, and mammoths was likely common. Imagine using a wooden spear to face down a multi-ton beast without wheels, pulleys, or armor. Only strength, timing, and fearlessness. You didn't just have to survive the kill, you had to survive the hunt. And most of the time, they did. But perhaps the most fascinating comparison comes when you place a Neanderthal next to an anatomically modern human of the same period. Early Homo sapiens, with our longer limbs and leaner frames, may have been faster, more mobile, and more mentally flexible. But in a raw contest of strength and toughness, it wouldn't be close. A Neanderthal would win nearly every time. Their skeletons are biological shock absorbers, their joints built for constant stress. Their grip strength enough to crush bone, literally. Even their teeth show signs of use beyond eating. Some studies suggest Neanderthals used their jaws like a third hand, holding hides, plants, or bones while cutting or scraping them with stone tools. Their mouths were tools, their hands were weapons, and their bodies were evidence of a species perfectly engineered, not just to survive, but to endure. So when people call Neanderthals primitive, they're missing the point entirely. These weren't subpar versions of us. They were an alternate solution to the problem of being human in an Ice Age world, where we used networking, storytelling, and long-distance travel to outmaneuver nature. Neanderthals stared nature in the face and matched it blow for blow. And for hundreds of thousands of years, it worked. They didn't need to build cities. They were the fortress. They didn't need clothes tailored for fashion. They needed hides that could keep blood warm after a broken bone. In an age of survival, they were the apex generalists, strong, smart, durable, and wholly adapted to a world most of us wouldn't last a week in. They weren't just tough. They were built by nature to conquer suffering, and that alone makes them one of the most remarkable human species to ever walk the earth. Chapter 2. Industrial minds in prehistoric bodies. If Neanderthals had only been biological powerhouses, that alone would have made them remarkable. But what truly shatters the old dumb caveman stereotype is the discovery that these Ice Age titans weren't just surviving physically. They were thinking, innovating, and building in ways that we once believed were exclusive to modern humans. For decades, archaeologists assumed that Neanderthal tools were basic, simple flakes and points, lacking finesse. But then came the birch tar. This wasn't just an adhesive, it was chemistry. Thousands of years before anyone knew what chemistry was. Creating birch tar from tree bark requires heating it in a low oxygen environment at precise temperatures between 340 degrees C and 400 degrees C. You can't do this by accident. You need knowledge of materials, fire control, and containment. In other words, a recipe. Archaeologists now view this as the first industrial process ever developed by a hominin species, and Neanderthals were doing it tens of thousands of years before Homo sapiens arrived in Europe. A 2024 discovery in Gibraltar took this to the next level. Excavations revealed complex hearth structures intentionally shaped to achieve consistent thermal output, essentially primitive kilns. These weren't campfires, they were heat-regulated devices built to solve specific engineering problems. It's no exaggeration to say Neanderthals had a form of applied science, passed from generation to generation. And speaking of generational knowledge, these weren't one-off discoveries made and forgotten. They were refined. That's what scientists call cumulative cultural evolution, when information builds over time, becoming more sophisticated with each generation. That kind of knowledge system requires not just intelligence, but communication, teaching, memory, and above all, culture. And where there's culture, there's often something more. Symbolism. The idea that Neanderthals had symbolic thought used to be laughable to many scholars, but now the evidence is almost impossible to ignore. In sites like Krapina, Croatia, eagle talons with wear marks have been dated to around 130,000 years ago, likely worn as necklaces or decorations. Jewelry, not tools. That alone breaks the stereotype because it implies something deeply human: aesthetics, identity, perhaps even ritual. And in Spain, at sites like Cueva de los Aviones, archaeologists found perforated seashells stained with pigments, dated to over 115,000 years ago, far earlier than modern humans arrived in the region. These weren't just objects, they were expressions. What were Neanderthals saying with them? We may never know for sure, but the act of creating art, of adorning the body, marking an object, making beauty, is a leap into abstraction, into imagination. Then came the cave paintings. For years, the stunning murals in places like Lascaux and Chauvet were thought to be exclusive to Homo sapiens, until uranium-thorium dating turned the timeline upside down. At La Pasiega and Ardales in Spain, abstract shapes, hand stencils, and red ochre symbols were dated to over 65,000 years ago, again, long before Homo sapiens had arrived in Europe. That means Neanderthals were likely the artists. Not accidental splatters, but deliberate, intentional markings, applied deep in cave chambers lit only by flickering flame. These were acts of planning, of placement, possibly of meaning. Even more subtle is their apparent use of feathers. Across several sites, bird bones show cut marks, but not for meat, just for feathers, black feathers in particular. Why? There's no practical function. Feathers don't make good tools, but they might make good adornments or ceremonial items. This kind of behavior, collecting rare colors, decorating the body, possibly performing rituals, points to a mind not just solving problems, but seeking meaning. Still skeptical? Let's talk healthcare. Meet Shanidar 1, discovered in northern Iraq. He's one of the most medically important Neanderthals ever found. This male had suffered a crushed eye socket that left him partially or fully blind. He had a withered right arm, possibly paralyzed from trauma, and deformities in his leg and foot that would have made walking excruciating. He also had advanced arthritis in his spine and joints. In short, Shanidar 1 was severely disabled by Stone Age standards, and yet he lived to about 40 to 50 years old, an old age for the time. The only explanation is care, long-term, daily, intimate care. He had to be fed, protected, sheltered, and helped to move. No modern tools, no hospitals, no anesthesia, just empathy, just people. As Dr. Penny Spickens of the University of York writes, Neanderthal healthcare wasn't based on self-interest or utility. It was based on compassion. It wasn't just Shanidar 1 either. Analysis of dental plaque shows they used primitive medicine, bitter plants like poplar that contained salicylic acid, the active ingredient in aspirin. Other Neanderthal teeth show grooves from toothpicks, the oldest evidence of oral hygiene in the human lineage. This isn't brute instinct. This is knowledge, choice, and comfort. And all of it, the tar, the tools, the art, the medicine, required one thing above all: communication. Could Neanderthals speak? Anatomical studies say yes. Their hyoid bone, a small bone crucial to speech, is almost identical to ours. Their inner ears were adapted to the same range of sounds we hear. And the FOXP2 gene, a key component in language development, was present in their genome. All of that strongly suggests Neanderthals could speak, maybe not with our fluency or metaphor, but with structure, syntax, and shared understanding. They needed it for hunting, for teaching, for passing down knowledge like tar making or injury care. Language wasn't a luxury. It was a survival tool. In fact, the biggest difference between us may not be raw intelligence, but in how we organized intelligence socially. Modern humans evolved with larger social networks, more flexible cognition, and abstract language that could scale ideas, myths, rules, memories, across entire tribes. Neanderthals, by contrast, may have had tighter groups, more concrete thinking, and less ability to adapt rapidly across large networks. That difference could have made all the difference later, when resources thinned, when environments shifted, when Homo sapiens arrived. But make no mistake, in their world for thousands of years, Neanderthals excelled. They weren't trailing behind us. In many ways, they were ahead. Pioneers of chemistry, medicine, art, and resilience. And when you understand the scale of what they achieved, with nothing but their minds, their hands, and their will, you don't see a failed branch of humanity. You see a parallel one, a mirror. A what if? A species that built, healed, and created without ever settling down, that mastered survival without agriculture or empire, that lived and thrived on the edge of human potential. The only reason their story ended is because ours didn't. But their legacy was already written in the tar they left behind, the ochre they painted with, and the genes they left in all of us. Chapter 3. When the ice cracked and the line blurred. For over 300,000 years, Neanderthals ruled the glacial frontiers of Eurasia, outlasting entire climatic shifts, enduring megafaunal predators, and mastering survival with bodies engineered by evolution and minds shaped by necessity. But around 40,000 years ago, something began to change. Slowly, then all at once. Their bones started disappearing from the fossil record. Their hearths went cold. Their tools, their pigments, their presence vanished. For decades, scientists called it extinction, a tragic, perhaps inevitable, end to an inferior species. But that word, extinction, misses the truth entirely, because Neanderthals didn't vanish. They merged, and their story didn't end. It dissolved into ours. The real mystery isn't why Neanderthals disappeared. It's how they stayed. The turning point was contact. Around 50,000 years ago, anatomically modern humans, Homo sapiens, began migrating into Neanderthal territory. What followed wasn't simple conquest. It wasn't war. It was something far more intimate: interbreeding. The first full Neanderthal genome, sequenced in 2010, revealed the shocker. Nearly every person today of non-African descent carries between 1% and 2% Neanderthal DNA. Later studies found traces even in some African populations, likely due to back migration. This was no one-time encounter. According to recent research, including a 2024 UC Berkeley study, genetic exchange between the species lasted for over 7,000 years. That's not a fleeting mistake. That's prolonged contact, shared lives, shared offspring, shared futures. These weren't monsters or enemies. These were cousins, and the genes they left us weren't leftovers. They were gifts. Today, Neanderthal DNA is linked to several immune system adaptations that helped early humans survive in unfamiliar northern climates. Genes related to keratin production enhanced skin and hair toughness, useful in cold environments. Other Neanderthal variants affected pain sensitivity, blood coagulation, even mood regulation. Some may increase risk for conditions like type 2 diabetes or depression, while others seem to provide resistance to pathogens. In short, Neanderthals aren't gone. They live inside us, shaping everything from how we process illness to how we respond to sunlight. Their disappearance from the archaeological record doesn't mean annihilation, it means absorption. But still, a question haunts the fossil dust. Why did pure Neanderthals, as a separate lineage, fade away? The answer lies in the fragility of advantage. For most of their existence, Neanderthals were perfectly tuned for the Ice Age. Their robust bodies, close social groups, and regional adaptation allowed them to thrive in relatively stable, though brutal, environments. But when the climate shifted rapidly, temperatures rising and falling unpredictably between 50,000 and 30,000 years ago, the traits that had once given Neanderthals dominance became liabilities. They were specialists in a world that suddenly demanded generalists. At the same time, modern humans brought something Neanderthals may have lacked: large-scale social networks, symbolic abstraction, flexible innovation, and the ability to coordinate over distance. Where Neanderthals relied on strength and tradition, Homo sapiens leaned on adaptability and connection. It wasn't a fair fight, but it wasn't a fight at all. It was an overlap, a phase shift, a merging tide. Genetic studies of isolated Neanderthal remains, like the individual dubbed Thorin, discovered in France's Rhone Valley and analyzed in 2024, show shocking levels of inbreeding. Despite living only a few days' walk from other groups, Thorin's lineage had been genetically isolated for over 50,000 years. This suggests that Neanderthal bands were becoming increasingly fragmented, their social networks fraying, their gene pools shrinking. It wasn't some grand defeat. It was a slow collapse, death by dispersal, and dwindling numbers. Meanwhile, modern humans spread like wildfire, not because they were better, but because they were more numerous, more interconnected, and more capable of adjusting on the fly. Still, even in decline, Neanderthals continued to intermingle, leaving behind not just traces of bloodline, but echoes of behavior. Some Homo sapiens burials show Neanderthal-style care. Some tools blur distinctions. The line between us and them became less meaningful with every generation. And that's the real story. There was no final battle, no last stand, just the quiet erosion of difference, replaced by interwoven ancestry. Neanderthals didn't fail. They transitioned. Their torch didn't go out, it passed hands. And yet, their biology reminds us of what was lost. No modern human today has the Neanderthal skeletal strength or shock-absorbing bone density. We don't have their muscle mass, their nasal architecture, their visual acuity. We traded the body of a warrior for the brain of a diplomat. It worked, but the cost was real. The last pure Neanderthal may have died 40,000 years ago, but the consequences of their existence are still unfolding in every cell of your body. Every time your immune system adapts to a virus, every time your skin weathers the cold, every time you feel empathy towards someone in pain, that's a whisper from a cousin who once roamed the glaciers. They shaped us. They made us. And they taught us that survival isn't always about dominance. Sometimes it's about merging, sharing, letting go of boundaries. So next time you hear someone call Neanderthals dumb cavemen, remember this. They were artists before we painted. They were chemists before we studied atoms. They were healers before we knew medicine. They lived, they suffered, they loved. And in the end, they didn't die out. They became part of us, written not in history books, but in our blood. Their extinction wasn't the end of a species. It was the beginning of a deeper, messier, more beautiful human story, one still being written every time we look back and ask, who were we before we were just us?